Okay, these notes are solving two-step equations. Okay, so they are called that for a reason. It should take you 2 steps in the solving process. Okay, so we want to solve the following equations by performing reverse order of operations. Okay, so you always need to be checking your solutions with these problems. Okay, so we're going to add and subtract first, then we're going to multiply and divide to isolate the variable. So isolate the variable means we want to get that variable completely by itself. I don't want anything else attached to it on the same side of the equal sign. Okay, so we're doing reverse order of operations because we're adding and subtracting first, then we're going to worry about multiplying and dividing. Okay, so our first example, we had a 5x plus 9 equals 24. Okay, so my goal here, and it's important to remember the goal, is that we are trying to get this x to be completely by itself. Okay, so right now, this 5 is connected to it. And then I also have this plus 9 over here that's technically connected to this x as well because it's on the same side of the equal sign. So my goal is to get this 9 to the other side of the equal sign and this 5 to the other side of the equal sign. Okay, so again, we're going to start with addition and subtraction. So because right now this is a plus 9, in order to move it to the other side, I'm going to have to subtract it so that I can get rid of it. Okay, so if I subtract 9 here and I subtract 9 from my 24, okay, when I do that, my 5x gets carried straight down. My plus 9 is gone because I just subtracted 9 from it. So that gave me 0. Equals 24 minus 9 is a 15. Okay, so my second step now is that a 5x equals 15. Now I can either multiply or divide. So again, my goal is to get this x to be by itself. So I've got to get rid of this 5. Well, right now, the current operation that's happening is this is 5 times x. So if I want to move that 5 to the other side, I'm going to have to do the opposite operation. So the opposite of 5 times x is dividing both sides by that 5. Okay, so I divide here by 5 and the other side by 5 as well. Remember, whatever you do to one side of the equation, you need to always do to the other. So 5 divided by 5 is just a 1x or just an x equals 15 divided by 5 is 3. So my final answer at this point is 3. Again, you need to be checking your answer. So in order to do that, okay, if x actually equals 3, then that means if I plug 3 back into my original equation where there was an x, this left side should actually equal 24 like my original equation said. So when I plug that back in, I have 5 times 3 now plus 9. I want to check and make sure that that actually equals 24. So 5 times 3 is 15 plus 9. 15 plus 9 is actually 24. So this checks out. 24 actually equals 24. Okay, so example number 2. 7 minus 4m equals 31. So again, my goal is to get this m to be completely by itself. In order to do that, I need to move this 7 and this negative 4 away from it. So I start with my value that is not being multiplied to the variable. So I'm going to start with this 7. Okay, right now, even though you don't see it, this is a positive 7. There's no plus sign in front of it, but we know that that's a positive value. So in order to move that 7 to the other side, I'm going to have to subtract 7. Okay, so I subtract 7 here. And remember, whatever you do to one side of an equation, you always need to do to the other. So I'm going to subtract 7 from my right side as well. 7 minus 7 is 0. That's what I wanted to happen. I wanted to get rid of this 7, so that cancels out. I carry down my negative 4m to my next step. And then 31 minus 7 is 24. Make sure you don't lose that equal sign. It has to stay in your problem the whole way through. So I have a negative 4m equals 24. Now, the current operation that is happening in this is a negative 4 times m. In order to move this negative 4 to the other side, I need to divide by negative 4. Okay, I'm doing the opposite operation that is currently happening. So when I divide both sides by -4, I end up with 1m equals -6. 24 divided by a -4 is a -6. Now again, you need to check your answer. So all that you need to do for that is take your answer that you got, your value for m, and actually plug it back in. So we're going to evaluate it for the value of -6. So 7 minus 4. Instead of m, I'm using a -6. So again, you wrap that in parentheses. Remember, anytime you're plugging a number back in, you should be wrapping it in parentheses. And then that equals 31. Okay, so now 7 gets carried down. Multiplication has to come first. Again, we're following order of operations when you're doing your check. So -4 times a -6 is a positive 24. And I'm checking to see if this really equals 31, and it does. 7 plus 24 is actually 31. So this checks out, which means that you got your answer correct. So you can always be making sure that you're getting these correct when you do them. Okay, 2 more examples. We've got 16 equals 5 minus y. Okay, now I know that you don't see a value in front of that y that's connected to it with multiplication, but remember there's always a 1 there. So this is really 5 minus 1y. Now again, I have to deal with this constant first. This is a positive 5 at the moment. The sign in front of it, even though we don't see it as positive. So in order to get rid of it, I'm going to have to subtract 5. Because again, my goal here is to get rid of this 5. So I want to turn it into a 0. To do that, I take 5 minus 5. I need to also subtract 5 on my other side. So 16 minus 5 is 11 equals, and I carry down my -y. Be careful to not lose the sign in front of the variable. Okay, remember the sign in front of something always is connected to it. Now I do have one final step here. This is a -y. I don't want to solve for -y, I want to solve for positive y. So again, remember there's really a 1 in front of that y. So this is really a -1y. So again, my final step is to divide here. I'm going to divide both sides by a -1. When I do that, that gives me my positive y that I needed. And then 11 divided by a -1 is a -11. So my final answer is that y equals -11. Now again, I need to check this to make sure that I did the work correctly. So I'm going to plug it back into my original equation. So 16 equals 5 minus a -11. So again, make sure that you're wrapping this value in parentheses. Okay, the value you're plugging in, that -11, needs to be wrapped in parentheses. So 16 equals 5. Now a negative times a -11, this turns into a positive 11. So 5 plus 11 is actually 16, which means this checks out and you got it right. Okay, another example. So 17.6 minus v is equal to 12.1. Now again, I'm solving for v. I want this to be by itself when I'm done. So I'm going to start with my constant. 17.6, it was positive, so that means I'm going to subtract it to the other side. When I do that, I carry down my -v. Do not lose that sign in front of it. So -v is equal to 12.1 minus 17.6 is a -5.5. Use your calculator if you're unsure. Now the final step. Again, I need to solve for positive y here, or positive v, sorry. So I want to get rid of this -1 that is attached to the v. In order to do that, I need to divide both sides by -1. When I do that, that gives me positive v equals a positive 5.5. Again, check your answer by plugging this value back into your original equation. When we do that, we do get that 12.1 equals 12.1. So from there, we know that we solved the problem correctly. Okay. All right, now the next example. And these are where you're going to start seeing fractions. Okay. The same rule is going to apply for these two. Right? So I'm starting with an x divided by 2 plus 5 is equal to 11. So I still have a constant out here that is not directly connected to my variable. So my process is the same as the last 4 examples. I want to start by dealing with this constant, which means I'm going to subtract the 5 to the other side. Again, I'm doing the opposite operation than what I see. This is a positive 5 right now, so I'm subtracting 5. I carry down my x divided by 2 equals 11 minus 5 is a 6. Now, this step is going to differ a little bit from the last problems. Right now, my current operation is that x is being divided by 2. So again, remember, we were always doing the opposite operation than what was actually happening. So if I want to get x by itself, if I want to isolate x, I need to multiply both sides by 2 here. The opposite of dividing by 2 is multiplying. So I am going to multiply my left side by 2 and my right side by 2. Okay, when I do that over here, my 2's cancel each other out. I am left with an x. 6 times 2 is 12. So my final answer here is that x equals 12. Again, you can plug that back in to check your answer. So 12 divided by 2 is 6 plus 5 is actually 11. Okay, next example. Same basic setup. I have a negative x divided by 3 plus 6 equals negative 11. So I'm going to start by moving my constant because it is not directly connected to my variable. If this was a plus 6, I'm going to have to subtract 6 to move it to the other side. So I carry down my negative x divided by 3 equals negative 11 minus 6 gives me a negative 17. Now again, my original operation is that I was dividing by this negative 3. So in order to undo that, I'm going to do the opposite operation. So instead of dividing, I'm now going to multiply both sides by a negative 3. On my left side, it cancels out my negative 3's, so I'm left with my x. On my right side, negative 17 times a negative 3 is a positive 51. Okay, so I was multiplying both sides by a negative 3. That's my final answer, x equals 51. So now I continue with my check, and I'm going to plug it in to my original equation and check to see that I got it right. Negative 51 divided by 3 is a negative 17, plus 6 is negative 11. So that answer checks out as well. Okay. All right, now the next 2 examples. We have a couple new steps here because our fraction is a little bit more complicated in these. So the first thing I'm going to do is undo this this addition or subtraction first. So I'm still dealing with my constant first, okay, which means in this example, negative 1, so I'm going to add 1 to both sides. Okay, so when I do that, I still have a 2/3 x equals 8 because I added the 1 to the 7. Now this is where this step is going to get a little bit different. I have a full fraction here of 2/3, so I cannot do what I did in the previous problems and just multiply by that denominator. What I need to do here is actually multiply by what we call the reciprocal. Okay? The reciprocal is simply flipping that fraction. Okay? So in this case, my original fraction was a 2/3. In order to undo that, I'm going to multiply by the reciprocal of it, which means I flip it and it becomes 3/2. Now remember, whatever you do to one side of the equation, you also need to do to the other. So I'm going to multiply both of these sides by a 3/2. Okay? On my left side, it's going to completely cancel out the fraction. So I'm left with just an x. On my right side, and you're going to need to use your calculator for this if you're able to. Okay? To do it by hand, it's the same as 8/1 times 3/2. All you have to do is multiply straight across. So you end up with 24/2, which is 12. Okay, so my final answer is that x equals 12. Again, plug that back into your original equation and make sure that you get 7 equals 7, which you do. Okay. We have one more example like this, which we're going to have to look at in the next video.